Coming up on This Week in Radio Tech, we're talking about Common Alerting Protocol. That doesn't sound so exciting, but wait till you see what it can do and the fact that it's being developed with some open source software. Rob Hopkins with OpenBroadcaster and Vincent Maggart, who's a software developer, are my guests coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcaster's General Store with outstanding service, savings, and support online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb there at the top of the tower. I'm Kirk Harnack, your host here in the Telos Alliance studio in Nashville, Tennessee. So glad to be here. And thanks a lot to Telos for making my technical life easy with great audio stuff and audio over IP here in the office, intercom, audio processing. It's all here. Thanks a lot. TelosAlliance.com is their website. So we've got a show today that I am ashamed and proud to say I know nothing about. But we got a couple of experts here who are going to inform us about this thing called Common Alert Protocol, or CAP. And it's, you know what? I thought it was just a thing for EAS in the US. I am so wrong. And if you thought that, well, you're so wrong too. So let me bring in our two guests who are going to inform us about this, because there was recently some kind of big hoo-ha convention about Common Alert Protocol. And we're going to find out what they learned there. And one of our guests, by the way, is a software developer. So that's going to be interesting too. We don't often get a software developer. But first of all, Rob Hopkins is here. Rob, welcome into This Week in Radio Tech. Good to see you.
Yeah, nice to see you there, Kirk. And hey, everyone out in Radio Land. I'm located up in Tagish, Yukon Territory, up in northern Canada by Alaska. And I do lots of stuff with open source broadcasting and streaming services, including CAP, Common Alerting Protocol. So it's really important, making relevant radio today. And one of those is being able to have unattended, timely emergency announcements for the local audience. So yeah, a lot interested to have a chat. And any questions anybody has, you can get them online. And otherwise, I'll just keep going on with our different stuff. So thanks again, Kirk, for inviting us back to your show.
And Rob, you were on before. Your lower third there says that you're a radio enthusiast at OpenBroadcaster. Would you give me a second and just remind me about what OpenBroadcaster is?
Right. So, we do general radio automation. It's a crowded marketplace with different systems. What makes ours stand out is that it's open source, meaning all the source code is available to the public. It's all web-based so that anybody can access our systems, whether it's a Mac computer or a Windows or a Linux. If you can get Firefox or Chrome, you can get access to it. And then the other thing that we really got into is in the emergency alerting side of things. And, that's like 15 years now we've been doing this automation business. And about 5 years ago, the CRTC made it mandatory that all radio stations in Canada had to carry this emergency alert system. And it was all based on CAP, which is an international standard. So we were able to make our software work with the CAP standard. So we're one of the few, if not the first, radio automation systems with a built-in emergency alerting system that conforms to the CAP protocol, which works in Canada, the US. 80% of the world is in the process of implementing CAP emergency alerting.
I'll be interested to hear about that. And also, I know that you're going to be telling us later on in the show about AI voices coming from some cloud services that can actually give some life. It's not perfect, Paul. It's not the sluggish Swede that the National Weather Service here uses. It may be better.
Yeah, and everything's been evolving with technologies for radio automation, and one of the big things is artificial intelligence, and so we're able to harness that machine learning into text-to-speech systems so that it will automate the delivery of emergency alert messages. The typical onboard text-to-speech is pretty crappy sounding, like Stephen Hawking on a bad day with a cold or something, but now with AI and machine learning, it can really pronounce stuff really smartly.
Well, I'm excited to hear more about that in a few minutes. Also with us here, though, is the other gentleman I mentioned, Vincent Maggard. Vincent from East Kentucky, Hayden, Kentucky, a town that I've actually been to many years ago. Vincent, welcome in. Good to see you.
Good to see you too. And I've been watching this show since I was a child. That's how long I've been watching it. So in my later childhood years. So it's a big dream to be on here with you today, Kirk. So I hope I can.
We've been on for 12 years, and the first 20 shows were audio only. So
yeah, well, it was my older childhood. Yeah, it was my older childhood, and I thought this stuff is so cool, and I learned a lot from you over the years.
Give me the elevator speech about Vincent Maggard. Who are we talking to here? What's all about you?
Well, I'm a filmmaker as kind of my hobby, but I'd like to make it more of a career. I do software development, and I'm the founder of SEKY VP LLC, a consulting company. We do software development for everybody you can name. Just recently completed a project in cooperation with OpenBroadcaster with the University of Kentucky, for example. So got some pretty nice and amazing clients to deal with.
So you're in Hayden, Kentucky, and that's not too far from Hazard, Kentucky. A lot of folks have heard of Hazard, Kentucky because of the old TV show Dukes of Hazzard, which I guess may have been Hazard County. But anyway, Hayden, Kentucky, that is deep eastern Kentucky in the hills and hollers there, isn't it?
It is. And I remember you were doing an episode about AM radio a couple years ago, and you were talking about the hills and hollers of places like East Kentucky being able to get AM radio. I'm thinking that sounds like my family's parents. They dealt with that. They were listening to AM radio in the middle of the night.
They may well have been listening to the Grand Ole Opry from WSM in Nashville, Tennessee.
They may very well have.
Covers, 30-some states, and their transmitter's just down the road from me here, 50,000 watts, and apparently gets out at night. So Vince, you're going to be talking to us about some software that you've been developing along with other software that's all part of CAP. So, hey, so folks, that is what's coming up on This Week in Radio Tech. We're going to be talking about common alerting protocols. So we can have the maximum amount of time to talk about it. I'm going to go ahead and take our first commercial break right now. To hear from our friends at Broadcast Bionics and the Camera One platform. We'll be right back talking to Rob and Vincent in just a sec.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
If you don't know about Broadcast Bionics, you ought to check them out. They make amazing software products that really help you create content, especially video content to go with your audio, or just improve the raising of information to you, the disc jockey, the talent, on the air. So check them out. You can go to bionic.radio. That's a good website. Easy way to get to them, bionic.radio. And hey, I want to make quick mention of my friend Ray Top over at Radio Guide. You can get to their website at radio-guide.com. And the thing about Radio Guide, this magazine comes out 6 times a year. This is the most recent September-October edition. They can go into deep detail with their articles, big articles, lots of pictures and lots of words, long articles to help you, the engineer, get up to speed on projects that you may want to do. Here's a project migrating, to tower light LED tower lights. So there's all kinds of good articles, timely, up to date, and relevant and all that at radio-guide.com. Okay, Kirk Harnack here in episode 468 or so of This Week in Radio Tech. We're talking about Common Alert Protocol. Rob, let's see. Let me ask you about, most of our audience, I would say the majority of it is in the U.S., most of our TWiRT audience. And so we're all familiar with the Emergency Alert System, EAS, the successor to the old EBS system, where we had the pink envelopes and the super secret words and all that kind of stuff. And the dreaded two-tone alert. Now we have the duck farts on the air, but I'm not sure if any of that has anything to do with Common Alert Protocol. Maybe you can demystify this a little bit for us. How is EAS done in Canada, and how is it related to Common Alert Protocol?
Right. Good question there, Kirk. And with Common Alerting Protocol, for one, it's international standard. ITU 1300 is the protocol, and it defines different events, priorities about emergency alerts. And so nobody wants to go and reinvent the wheel and start creating new protocols when there's already something which is robust and under development. So we had Canada, north of our neighbors in the U.S., about 1/10 of the population, but we're very similar in so many different ways. And so I guess Canada's been talking about an emergency alert system for many, many years, and there was all kinds of different schemes that were developed, but they were never really implemented because everybody had different protocols, and they had a working group eventually settled on the CAP alerting protocol, and back in 2015 they made it, CRTC, our regulator, made it mandatory that all radio and television broadcasters in Canada had to carry this emergency alert system. And the way they set it up was they provided an emergency alert feed, a CAP feed, and boxes would subscribe to that feed. And if a CAP alert properly formatted with the information about your small town or your province came in, then it would cut into the radio and TV and broadcast a CAP alerting message. And so the way this was rolled out was that they made the service a free offering, but it was up to the stations that had to buy the equipment to interface to this free service. And they made it mandatory. They gave it a couple of years and a big extension to the community radio sector. And it was during that time that I'd been following the CAP protocol, and I was able to make our systems work with the CAP emergency alerting, not just with our in-house automation systems, but also as a standalone service. And it was a real challenge because, as everybody out there viewing this right now has a different radio station. Every radio station is different. You have a different mixer, you have different audio path to the transmitter, all kinds of different variables. So anyhow, we learned a lot about how to interface with different systems. And the CAP alerting, the way that it works is you have a station, for example, in my house or my studio, those orange boxes there, those are running radio stations. They're monitoring an XML feed from Toronto area, and from a company called Pelmer X Media. They also run the Weather Channel. And I have a code for my neighborhood here in Tagish. It's a small community. They use census codes. Every 5 years, somebody comes around, does a census, and they take the census code for that neighborhood. So when my boxes and radio stations are monitoring the feed, and if they see a message that matches with their location, then it will then grab that and interrupt the programming and play that on the radio or the TV. They since have included this CAP alerting protocol feed through wireless emergency alerts with cell phones, smartphones. That's just been in the past couple of years that they've rolled that out. So, CAP is the underlying mechanism about how to receive the message, how to prioritize it, and how to play it. And where this really comes in with emergency, a small town where you get one fire a year, one message come through, that's not a big deal. But what happens if you have multiple overlapping regions, even on the Canada-U.S. border, and then you have multiple emergency alerts coming in all at the same time? How do you prioritize that and get the thing on the air so that nothing gets missed? So that's some of the challenges that we have with the emergency alert system in Canada. Also in Canada, the emergency alert system supports Canada's a bilingual country, so the emergency alerts will be broadcast in French and or in English, depending on which area of the country you're at. And the protocol for CAP also includes different languages besides French and English. So in the U.S., Vincent, our counterpart, can describe more about how that works with Spanish language. But in Canada, the emergency alert system actually supports Indigenous languages. So in Canada, we have something like 650 distinct Indigenous groups. There's something like 30 languages that are still spoken to some degree, and so our whole emergency alerting system in Canada will support those Indigenous languages. But right now, I'm the only company that manufactures equipment that can receive those emergency alerts, and I've not actually seen that used much, especially in northern Canada, where we do a lot of our operations at. So CAP's a really interesting thing, all about prioritizing emergency messages, and there's all kinds of security protocols. It's a well-defined standard, and this is where 2 weeks ago there's an international CAP conference that gets together every year. And they talk about how different countries are implementing CAP, and all the different solutions that are out there, and different challenges about how this protocol works. So it's a really interesting topic.
So I'm beginning to get a bit of an overview here. I want to come back to you with a question about that, but let me run over to Vincent for a minute here first. Vincent, you heard what Rob said about CAP, kind of an overview and a profile. Is there anything that you'd like to add to that, or anything you'd like to emphasize that Rob said about CAP in Canada?
Yeah, so I mean, a couple things I would like to emphasize and add here. First of all, CAP is a standard that, of course, is ITU, and it's used everywhere. So that's, everywhere. It's amazing. It's being used in college campuses for private alerting, like of school cancellations and such. It's not just used by emergency management. And then on the U.S. side, the U.S. emergency alert system is, as I'm sure you know, Kirk, it's not completely CAP. It's actually only partially CAP, because the National Weather Service, while they issue CAP messages, they only currently go to the wireless emergency alert system. They don't have them go out to broadcasters. They still have the daisy chain for that. The other thing about the U.S. and Canada, there's different CAP profiles. You can kind of think of them as accents or something, right, in English, right? You might be from Canada and still speak English, but you do it in a slightly different way than maybe I would from Kentucky. It's kind of like that with profiles. There's, in the U.S., a profile called the IPAWS profile, which is what broadcasters and different people may use here. And then there's also the Canadian profile for Canada. Now, you don't have to use those profiles unless you're in a system that needs it. For example, in the US, if you had your own private CAP server, you could generate a non-IPAWS formatted message. You don't really need that unless you're generally going out to broadcast or one of the other systems that things like IPAWS is connected to.
Okay, starting to get a picture here. So, are you? Would I understand that iPause is either a subset or a flavor of CAP?
Yeah, you could say it's like a flavor or a subset. It basically adds on additional things. For example, the emergency alert system has originator codes, right? The regular version of CAP doesn't have that, but there's a mandate under the iPause profile, of course, for broadcasters to have that in the EAS header. And so, how do you declare that? Well, you do that in the XML of the CAP alert, and that's in part of the profile spec.
So maybe you can answer one more question right here, and then maybe Rob could comment after. So, of course, in the U.S., we started out with this daisy chain EAS, where my radio stations may be listening to another station, which had to get its alert from another station, and the audio quality can suffer pretty badly. And also because I think a lot of stations, if they hear there's some audio on their over-the-air monitoring requirement receiver, then it's okay. I can't say that people really give a lot of effort into optimizing that. So in the U.S., on-air EAS can sound pretty bad unless we get the message first from our state server. Is it the case in Canada you don't have the daisy chain radio station relay? Is it just internet digital relay?
Yeah, it's just internet access, so the alerts are just sent as a push to the boxes. So yeah, there's
Okay.
no radio at all.
Rob, maybe you could expand on that a bit for us.
Yeah, good question. And that's there is a difference from what I gather in talking with different groups in North America and the U.S. about emergency alerting. So in Canada, we designed our system from the ground up, and they launched the thing, and it was one emergency alert, a NAD. I'll explain what a NAD is: National Aggregation and Dissemination. So the way that somebody gets an emergency alert in the Yukon, for example, where I live, is they send the alert to Pelmrex Media. They're an aggregator, and then they take that emergency alert and then they put it into their feed. So the local authorities don't directly access our transmitters; they send it to Pelmrex. Pelmrex then turns it into an emergency alert feed. And so in Canada, we have one NAD. That's Pelmrex, the Weather Network. And from my understanding, in the U.S., you have something like 170 plus different NADs that assemble all these emergency alerts. And one of the maybe frustrations, or it's just the way it is the U.S. supports legacy emergency alerting from like 40 years ago, which is good because there's infrastructure and protocols in place. But whereas in Canada, they did it all straight IP, so there is no daisy chaining or relaying of alerts like that. Each station has its own unique identifier and location, and it handles its emergency alerting. And the other thing which is different about Canada is that stations in Canada are obliged to carry emergency alerts, but there's no local generation of emergency alerts. So a radio station can't issue a CAP alert to other radio stations. They can, of course, cut into their own radio station, but they don't have to do the weekly tests and relays like I hear about in the U.S.
Gotcha. Okay. Wow. It's interesting how this is different in different places. Vincent, we're after our next break, we're going to get into the whole open source software portion of this and how that fits into this national and even international effort to make common alerting protocol available and easy to disseminate. So people, the whole idea here is so that people can get alerted to things. Vincent, maybe you can talk a bit more though on how these alerts get out, how they're initiated, and I'm sure I'll have Rob talk about it too, but about the software or equipment at the station end of things that picks these things up and does something with it. What can you add to that?
Okay, yeah. So, first on equipment, any computer in theory can process a CAP alert. It doesn't really require any like specialized hardware. In the US, for example, if you have like a Sage 3644, the digital index, for example, they have CAP support built in. as do pretty much everybody's boxes these days from what I've seen looking around. And then in Canada, there's equivalents from a lot of those vendors, like, for example, Sage and DASDEC, digital alert systems, both have boxes for the Canadian market. But the actual dissemination process, as far as how that works, basically depends on the originator, because there's different tools, especially in the US. There is an aggregation, kind of like the NAD in Canada, called IPAWS. And that's where most cap alerts are. But states can set up their own, or cities if they want to as well. But what happens generally with all this origination is they go to, let's say there's a tornado or something, or, well, it wouldn't be a tornado. Let's say it's like an Amber Alert. They would go to a centralized, usually web interface is most common, and they will select from, a simple user interface. Okay, this is an Amber Alert. It's going to be in effect for 2 hours and 20 minutes, let's say. And this is the alert message I want to scroll on televisions. This is the text I want to be converted to text to speech for radio. And then they can also add optionally a MP3 file or other file attachment, like a photo of, say, the child or something, if they were abducted.
Okay. All right. Rob, we're going to break for commercial soon. Anything you want to tell us more about the dissemination side of this? But when we come back, we'll talk about the open source software aspect of this and how that plays into the commercial products available too. Anything you want to add?
Yeah, not too much on the dissemination side of things. It's mostly just an XML feed. You point your box to a server, and it sends out a heartbeat. A heartbeat is just a ping, just saying that the box is there and that it's connecting. Once you set up one of these boxes, you don't have to go and babysit it or anything. It just sits there. In Canada, typically in a small town like where I live, you might get 3 broadcast intrusive. The ones that you have to broadcast, you might get 3 of those a year on a busy year. So it's not used. It's used very, very sparingly. They don't want to have it over subscribed. I know back east, when they were testing the wireless emergency alert with smartphone handsets, they would send out a bunch of alerts at 2:00 in the morning that just killed everybody in Ontario. 1 million people had a crappy day having to respond to that. And then other people, they get emergency alerts. They go, not another one of those things, and put the thing on mute, and it goes away. So they reserve that for very, very special purposes.
Well, I'll tell you what, I'm going to ask this, and when we come back from the break, I want to ask about the server infrastructure, how that's handled. I thought maybe I misunderstood, but I thought maybe you spoke of a commercial contractor who operates the head end for all this, but maybe I misunderstood. So we're going to get the answer to that when we come back. I'm curious to see how that works in Canada and maybe compare that to how it works in the US. And I'm sure there's backup. I'm sure there's redundancy in the system. I would hope so. And if there's any regionalization in the server infrastructure. So I got all those questions coming up this week in Radio Tech. I'm Kirk Harnack. Our show is brought to you in part by our friends at Angry Audio. And I got something to show you right here. Angry Audio has Studio Hub. They bought the whole Studio Hub company, lock, stock, and barrel, and all the jigs and the people. Well, they didn't buy the people, but they still have the same people making the stuff. So I just bought a bunch of these recently. This is the female XLR to RJ45. This makes wiring your studio so much easier when you're going, even if you're not using AOIP to go from this to into like an X node or a Blade. You can. This is good for analog studio wiring too, and even AES-EBU studio wiring where you just have one balanced pair. So they got all the Studio Hub stuff, and they're adding to the Studio Hub line all the time. So check this out. This is so new. It's not even on the website yet. This is the World panel, or the Universal Interface panel from Studio Hub and Angry Audio. It's not a passive device. Now, it does have a couple of passive connectors over here to pass through USB and RJ45 for your network connections. But the audio connections, AES-EBU and analog, whether it's balanced or unbalanced, or even the little 3.5 millimeter tip ring sleeve, these are all buffered. There's electronics in here that does the buffering. So you could have a TV crew come in and hook some bad equipment up to this, and your on-the-air broadcast remains okay because the active electronics in here will buffer between whatever mistake they're making and your own equipment. So you don't risk your equipment. I encourage you to check this thing out, although it's not on the website, so you can't exactly check it out yet. It'll be on in the website in the next couple of days or so. So you've got analog in and out on the different style of connectors that you need, and AES-EBU in and out. On the back, it's all Studio Hub connections. right there, RJ45s. This will go to your Axia X node or right into your radio systems console or whatever you have that takes RJ45. Or of course, you can use these adapters to get into whatever your console or system has getting out. So check that out. That's from Angry Audio. The website is angryaudio.com. I encourage you to, there you go, right there. They have a whole slew of new products that you're going to want to make sure you know about. They're really helpful for you building new studios, adding things on, making your life more convenient. And of course, they have those headphone amps that I talk about most of the time. Hey, This Week in Radio Tech is also brought to you by our friends over at Max Connect Wireless. They'll help you get connected when you're on remote or in a remote place, like a transmitter site that has no other internet access with 4G LTE modems. Let's hear a testimonial. We'll be right back.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It has also given us the ability to expand as needed in a secure fashion.
And look, I've got both kinds of LTE modems, country and Western, so to speak. This one is the one from PepWave, and this one is the one from Cradlepoint. It doesn't matter, though, which of these you're using. What matters is the SIM card that goes inside from Max Connect Wireless. Yeah, they are a carrier or a reseller of carrier. And what they're reselling to you is priority access. You get priority before everybody else in the stadium for your data, except, of course, for first responders. And shouldn't be anything going on there. So you get lots of good data to your transmitter site or to your remote broadcast, even when the stands are filled with people doing their Facebook updates. Thanks a lot, Josh Bone at Max Connect Wireless. It's spelled funny. You can go to Max with two X's, Connect with a K, maxconnect.com. Of course, we'll have a link to that in the show notes. So if you're traveling right now, just go to our website, thisweekinradiotech.com, and click on the link for Max Connect Wireless. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee, and our show today is about common alerting protocol. And we have a couple of experts on that. Vincent Maggard is a software developer in Kentucky, and we're going to talk to him shortly about what software he's writing. And then also Rob Hopkins is with us with OpenBroadcaster, and he's he does all kinds of cool things in Canada, out there way in the Yukon. Hey, let's bring in Vincent for a second. Vincent, one of the bullet points that I wanted to talk about is how open source software specifically can help with public alerting. So what's that relationship? So it's not proprietary software. It's open source. Anyone can look at it and people can even improve it if they need to.
Yeah, that's correct. With open source software, one of the beautiful things about it is that anybody that wants to can, improve it. So if you see something in the code that you say, you know what, I think this could be done better, or I see a bug in the code, for example, that, could cause a bad thing to happen, well, then you can go in there and fix it and submit a pull request, as developers, we call it, to let the developers of the project know, hey, we've got some improvements for you. You should take a look and see if you want to include them. Now, as far as, go ahead.
Continue on.
Yeah.
Got a delay here. Sorry.
The delays. Yeah. So the emergency alerting side of it, for emergency alerting with software that's open source, I think the real advantage for that is that you have a lot of small stations, community stations, such like that. In my area, I have, dealt with some of the radio stations, not like professionally, but just know of them. And from what I've heard, some of them have really low budgets, right? Radio is not, like television with millions of dollars, to do, a 10-minute remote. Okay, maybe not that, but still. So when it comes to emergency alerting, having something that you can put on a computer that you already have set in there and just, route that into your audio switcher and have it trigger to switch to it and such, that's something that's very powerful. And things like OB Player, for example, can do that. You can give it, output of your audio board, your audio console, your program out. And then when there's an alert, we can insert right into that, emergency message. And then when it's over, we just bring your audio right back up. No problem. So that's something you can definitely do. And because it's open source, you can do that on a standard computer, or you can get something custom built. Of course, the officially supported ones from OpenBroadcaster, are a little pricey because that includes support and such. But
All right. So this software that's running on, you call it the OB player, the Open Broadcaster player. Is that stands for?
Correct.
So it's
yes.
sitting there connected to the internet, and then it's also got, what does it have, your station's program audio routed through it like an EAS box would have?
It can. It can also
Okay.
be doing the program itself. So, for example, if you were a community station, all your content's pre-recorded, you don't need an audio console in the middle of it for some reason, you could have all that pre-recorded, put in the OB server, which syncs with OB player, and then when there's an alert, we can interrupt that and have it all on that computer, not even have a separate device involved at all for the alerting or the programming, just one box.
Okay. Let me give me the scenario though. Let's say I'm not using OB Player. I'm not using that on-air system, but I'm using some other commercial on-air system or live disc jockeys part of the day. I could still get could I still use the OB Player to handle these CAP messages and insert them for me?
Yeah, you can. And what you do in that situation is you take the audio out of your board and you go into the OB player and you tell it, don't use you for the programming. We want to use us for the programming, our own board and our own automation. And then once you do that, it will just interrupt it when there's an alert, and you can take the audio, loop it back out, send it to a studio to transmitter link. It can also stream directly to IceCast out with that. So if you just want to go to the internet, you can have that all handled there. So there's different ways to do it.
So now this message that comes in from a CAP server that I've said, hey, if it's this message, if it's for this geographical area where I cover, I want to take this message. Okay, it's coming in as some kind of digital messaging. Is it text? Is it binary? Is it an audio file? Is it what's coming in over the internet, and then what's happening to that so it goes on the air?
Okay, so what's coming in over the internet, either via push or pull methods, which are both different. At the end of the day, it's a XML file, and XML is really weird looking text. It's not the most human readable, but it is still text. If I showed you an XML file, you would recognize it as English, but you would be like, what's all those weird characters around it? Called tags, and that will include things. For example, there's a tag that might include the event, and there's a tag for the description. So the description is part of the text that would go over the air. So the box, like an OB player, for example, and others, they're going to look at that description, that instruction. There's also usually a headline tag, and can combine those together. Depends on where you are. Like in the US, for example, we don't use the headline tag in the official spec. If you look at the official spec, which is available online, of how to do this, it only says you should be including the instruction and the description. It's description first, and then the instruction following it. But in places like Canada, that's not the same. So at the end of the day, we're either going to convert it to text to speech, right? And we're going to do that over the air and then play it for you, either using AWS Poly or onboard TTS. Or we're going to go out, if there is a audio attachment to the CAP alert, because you can do that, and host it on a web server, and you can say, hey, I got an alert over here, I got a message for you, or, somebody at the EMA, let's say, recorded it, then you could have that downloaded and play that instead. But if that alert doesn't come in, we can still do TTS as a backup.
Okay. All right. I'm starting to get the picture here. In ways, it sounds a bit like EAS with some added features. Let me ask Rob about this. You mentioned Vincent mentioned AWS Poly or AI Poly voices. I haven't heard of this, but I'm sure AWS is. We most of us have a box of. Well, here's one nearby. She who shall not be named, otherwise known as the Speaker of the House. You know her name. I ain't gonna speak it. So I guess Amazon certainly knows something about text-to-speech. Rob, what can you tell us about Poly voices?
Right. So Poly Voices, and that's an Amazon Web Services thing that we have tied in with our emergency alert player, and also we have this used in our production for PSAs and commercial advertising. But in regards to the emergency alerting, the protocol in Canada, so your station, a radio station, for example, receives, subscribing to the feed, it receives the CAP alert, it matches up with the location. So what it'll try to do, it'll first see, is there an attachment that was issued with that CAP alert? So sometimes they will issue the CAP alert as an MP3 file or a WAV file. And if that file is present and it's not corrupted, then it will then play that file. And let's say they send an emergency alert and it matches up, but the MP3 file was corrupted and it won't play, or they didn't issue the message, then it will then go into the the description and pull that text information out, and then try to use an onboard text-to-speech system. And I was saying earlier, most of them, you can tell that it's a computer, and it doesn't sound very high quality, especially the open source. Yeah, hey, it's free. You get what you pay for. But anyhow, since then, in the past few years, Amazon has come up with a service called Polly. It's a AI text-to-speech engine. And so the same thing will happen in our systems. You set up a few menu items, you get a key from Amazon Web Services, you put it into our systems, and so what will happen is an emergency alert is sent to one of our stations. If the MP3 file is there, play the MP3 file, the attachment. If that is missing, then use text to speech. And so it will then, if the Polly is enabled, it will then take that small text string, it will send it through the back end to Polly. It will then will then turn it into an audio file, send the audio file back, and then that will then get injected into the broadcast chain. And if something happens, Amazon Web Services is down, then play the onboard text-to-speech. So there's an established protocol about how things get played and what order and what priority. And quickly, for the TV side of things, it will play all the audio like I just described, but it will also play a JPEG image if it was sent, and if there is no JPEG image, then do a red with a white overlay of the description. And just to follow up on something that Vincent was saying about the different ways that alerts are injected in the broadcast chain. Oh man, I got no hair left from having to deal with all those different scenarios. Some of the other ones that Vincent didn't get into, there's so many MP3 on demand. So you can set up our player box so that it will only issue audio out of the local sound card or an MP3 stream if an alert is in progress. So what happens is alert comes in, creates the MP3 mount point on IceCast, it plays the thing, and then when it's done, then the IceCast mount point disappears. We have stations using that. That's all software. Then we have other stations that have different mixing boards, audio IP, Telos boards, beautiful ones we've got in community radio stations. And some of those will use a GPIO function set up on those. And so that if there's an emergency alert, then there's a DB9 connector output, and it takes pin 4, makes that high. And then when the alert is finished, and makes that switch disappear. So many, many different ways to inject alerts into the broadcast chain.
Well, tell you what, maybe both of you then could tell me about metadata, because so many radio stations certainly have an RDS feed, or if you're an HD radio station, you've got a place for PAD, program-associated data, or I guess in this case, not program-associated data. And if you're streaming, you may have a player, a web player app that includes some functionality for text. Let's talk about that topic of taking this text and not converting it to speech, but putting it out as text. What's available?
Oh, you go, so Vincent, on the internet, you're the expert.
Okay. Yeah, on the internet streaming side, I'll talk about that first, as that's really where that I've got the most expertise. With IceCast, we can interject with to the server with metadata that is sent down the line separately from the audio, as you may see on a lot of web streams, right? And OB Player does support sending some basic information about the emergency alert down the line. So it will say there's an emergency alert playing. Presently, it doesn't say much more than that. Realistically, we're expecting you to be listening to the audio, but it will let you know if you're just kind of glancing at the screen, hey, that beep a second ago, that's an emergency alert. I need to get my attention going. So, because that is a small amount of text we can put there. So usually, you can't put like a full alert message there, but you could put something like what we put right now. It says emergency alert message, if memory serves, or emergency alert. So okay, there's an alert playing.
Okay. Rob, what can you add to that?
Different CAP is used for many different uses besides just radio and television. So electronic message boards you see on the highways and stuff, some of those are CAP based. So one of the big players in LED signage, bright sign, our player will support that protocol. And so you have a player box, you have a DB9 cable connector, goes to RJ11, I believe, or RJ9 little cable, goes to an LED sign, and it will take the CAP alert and will then send that to a scrolling message board. It'll change the colors of it too, depending if it's a priority or an advisory. So there's lots of different ways that emergency messages get sent out besides just radio. And for streaming, generally, you want to disable emergency alerting on streaming because if there was an emergency alert in my town and people are listening to the radio stream, then hey, that's great. They know that there's a flood happening. But if somebody's listening to the stream in Germany and it says evacuate your house because there's a flood, well, that's not really relevant. So streaming, that is not mandatory to carry emergency alerting on web streams in Canada.
Gotcha. Okay. Is anybody doing any, it wouldn't be geofencing, but, geo-targeting? Okay, if there's any CAP alerts, those should only go for the listening area of the radio station, and the stream, anybody subscribing to the stream outside of that area should just continue to get the regular stream. Is that even possible?
Yeah, it's difficult to do that because when somebody is listening to a stream, you don't know, you're telling what server they might be using, some proxy server. It really doesn't work well for that side of things. But for hyper targeting of CAP alerts, yes, absolutely, especially in big cities. So they do what's called a polygon when they issue the CAP alert. They draw on a map, the area that they want to alert, and it can be a street or a block or a city or the entire province or the entire country. So you can really fine tune where those CAP alerts are going to be sent to, and that really comes in with cable TV, local radio. Very, very, very relevant. And one of the things that we're all trying to do with radio is make our industry more relevant. Advertising. You go to somebody, they say, well, why should I support your radio? Right? Well, we're local, and they say, well, yeah, so is Google and so is Facebook. No, we're really local. So CAP alerting is actually something which does bring a lot of relevance to radio. People want to know what's happening, like in my town or in my house right now. So it's a very, very important service to have. And in Canada, and I think in US, it's mandatory as well.
So if I have a CAP a box at my broadcast facility, let me put this question a different way: who is allowed to connect to a CAP server and say, "I'm here, I'm ready for any messages"? In other words, could homeowners do this? It'd be easy to overload the system, I would think. So, how is conditional access performed?
Yeah, in Canada, that's a public feed. You can just type in the web, and you can see the feed. And this is with software as well. You can run this on old computers from the dump, or you can put it onto newer hardware. Some of the cool stuff that we work with is these guys in here. This is the turn it around here. This is the Raspberry Pi 4 with a XLR balanced audio output. So this can be set up as a CAP receiver. It receives the feed, and then when the feed plays, it sends it out balanced XLR to your broadcast chain or a silence detector, and something like that's $100-200 for something. We also have some higher end products. This guy is made in the U.S. And white label branded. It's a regular computer, solid state, no moving parts in it. The thing will go 150 years before the thing's going to break down and stuff. So the big barrier to some of the community stations and indigenous radio stations is the cost of equipment. If you're walk in off the street and talk to a broadcast engineer, you're going to get quoted thousands of dollars, rightly so. And the big commercial broadcasters, that was a tiny little piece of their budget. It made no difference at all. But all of a sudden, you go to a small station which gets $500 a year in a grant, and they've got to come up with money for this emergency alert thing. Very, very difficult to do. So some stations have bought our systems. Other ones have used the Raspberry Pi. We supply a complimentary image. Has all the stuff. You can plug it into your emergency alert thing and be ready to go. And then we've got other stations that just use the open source software. And one of the things I love about open source is number one, giving back out to the community, and good karma always comes back. And so somebody will get into our software and start figuring it out and say, hey, did you know there's a bug there? Or, hey, I just made a simple fix to it. And that's how I came across Vincent. Never heard of Vincent at all. And then I saw a video of a thing and emergency alert, and I said, hey, that's our stuff that they're reviewing. And I've been Vincent and I've been working together ever since. That's a few years back. Anybody who wants to hire Vincent, man, does great work, loves Kentucky Fried Chicken.
Well, he's not too far from where Colonel Sanders started the whole thing, so there you go.
That's right. That's right. And we call him the Colonel too, by the way. That's his nickname here.
We do?
Colonel Vincent. Well, we do now. Hey, in fact, Vincent, one of my bullet points here is to ask you about your CAP tool. Have we talked about that yet?
We have not. And I would love to, of course.
Yeah.
So in the last few months, have been working on a tool I'm calling Common Alerting Central. And so if you are in a nation that doesn't have a CAP server, it's open source. You can check it out and use it. You don't have to pay me a penny. That being said, you could also use it for different things. The reason I ended up developing it was because I was thinking this would be a great use for my family, talking about using it for non-emergency management purposes, because one of my family members is sick, and I wanted a way of being able to push out an alert to the family all across the country in a matter of seconds. And CAP is wonderful for things like that. I haven't actually rolled it out to them yet, but it's something that definitely can be done with it. So the CAP Alerting Central tool, what it is, the Common Alerting Central tool that I've developed, it's a web-based application. And what it allows you to do is to go in and compose messages and then have both push and receive. You can push messages to push clients, and you can have them pull from you if they're a pull client. So what that means is all kinds of different things can work with it. I have a buddy that does software development. He has a Sage, and he's hooked up his Sage to my system, and it will work with the Sage. It's a little flaky with the Sage. They clearly never intended to be hooked up to something like that, but you can point it to it if you tweak the settings correctly. That being said, I do know it works really well with OB Player. I made sure of that. So if you have an OB Player that you want to send alerts to, you can do that with it. So there's a variety of things, but right now it will generate IPAWS formatted messages and Canada formatted messages. So in the future where it's open source, if anybody out there's got expertise with other profiles and would like to help, that would be great. It's on GitHub.
So I'm just trying to connect the dots here. So if I'm a family member, what device am I receiving this alert on about the health or wellness of my dearly beloved relative?
Okay, so the plan for that, I developed a web-based client that uses JavaScript in the web browser. I haven't open sourced that, by the way, but I'm considering it, so be on the eye out on that. But what it does, it sets in the web browser, and when there's an alert, it will just pop up a little notification, desktop notification like you can have on Chrome, and say, hey, there's an alert. I also considered building a mobile app for people's phones. I also have a simple desktop application. It's a little Python script. It's not even that big, and it will sit there and talk to the server. And when there's an alert, it will just pop up a little window on your Windows machine, Linux, etc. And that little program will allow you to do it. But everything I'm doing is all standards-based. So in theory, even if you don't have one of those tools, it shouldn't matter. You can either build your own, or you can, go out and go to one of the vendors that already has some of the tools out there. I know of some companies like, for example, Informacast. If you have a phone system like Cisco and Avaya, you can do emergency alerting with CAP using that, both through IPAWS and in theory through my system. I say in theory because I haven't tested it, but they support the same pull method. So in theory, but that's the power of CAP because it is open source. you can't, open standard, and you've got open source implementations both on the client and the sending side. You really could conceivably build a completely open environment for CAP where you don't have to spend thousands of dollars, which could be very useful.
Really interesting. You could call everybody home for supper or tell them about how Aunt Mabel's doing. Good news or bad. Hey, baby born 8:41 this evening. 8 pounds, 21 inches long. It's a girl. That kind of thing. So.
Yeah, you could.
Wow.
I don't think I would issue a CAP alert to a family like that unless it was something serious. You don't want to do alert fatigue. I've talked to a few people that work with the National Weather Service before, and they say, if you issue an alert that's a false alarm, even if you thought it was correct at the time, if they start to hear one or two of those, they just tune out. You don't want that, obviously, right?
Hey, we're almost out of time, but we're going to hit our last spot break. When Rob and Vincent come back, I think they each, I hope I'm not speaking, I want to hear an interesting story about, what's the most crazy alert you've heard of? What's the strange circumstance? Was it a moose? Was it a bear? Or was it something else? I'd like to hear about that because we've only got a couple minutes left after we come back. So I'm sure you've got a crazy story about how CAP has been used to alert the natives, the local residents. Our show This Week in Radio Tech. I'm Kirk Harnack. I'm in the Telos Alliance studio in Nashville, Tennessee. And our show is brought to you in part by our friends at VoxPro. We'll be right back.
Hey, what's happening? St. John here, coming to you from Command Central, and wanted to tell you about the absolute best partner you can have in radio. I'm talking about, boom, Wheatstone's VoxPro. Lots of different audio software out there. Why VoxPro? It's the only software designed to do what we needed to do, which is record, edit, playback in real time. When I say lightning fast, I'm going to show you how fast you can edit stuff up in VoxPro right now. So literally 3 clicks on the controller, mark left, mark right, everything that gets marked, you hit delete, it goes away. It's literally that fast. So we're going to take this part right here.
Caller 9.
Boom. From caller 9 to him saying, I'm ready.
5. Ready for that secret sound.
Boom. All of that stuff, hit delete, it goes away. Here's your edit.
You are tackling secret sound, caller 9.
I'm ready, St. John.
So one of the best features of version 7, this is awesome. It's effects macros, and you can literally put a chain of effects together so that instead of having to normalize a phone bit and then use noise reduction on it and EQ it and all that, you can literally build a chain. One button, this one's called call right here. I just click that. All of those processes happen instantaneously. Final thing that I love about VoxPro, and there's so much more to get into, but one of my favorite things, you can load it on a laptop. I've literally done my show from a hotel room in Armenia to the conference room at, this was fun, jury duty. Great thing, no one could tell the difference. VoxPro makes it totally easy. Telling you, if you're looking for the best on-air partner, call my friends at Wheatstone, ask them about VoxPro, and you will be glad you did.
Actually, you can call the folks at Broadcaster's General Store, BGS. The website is bgs.cc, and the phone number is 352-622-7700. That's 352-622-7700. They are set up to talk to you. Real people. How about that? Not recordings. Real people who know what they're talking about. I'm glad to get you a quote right away, sharp pencils and all that, and tell you how long it'll take to get delivered. Thanks a lot, Broadcaster's General Store and VoxPro, for sponsoring This Week in Radio Tech. All right, Rob Hopkins is here and Vincent Maggart's here. And gentlemen, can you relate to me a story or two about how CAP has saved the day? Are they here?
Well,
I'm here.
Okay. Yeah, okay, go ahead.
Yeah, I'll go on. I got a couple of things. I remember when we first got our systems running, you could select French or English. I remember I did some weird mashup of the configuration where I had the language is English and the text-to-speech engine is French. And then when an alert came out, it sounded like a really drunk, arrogant English butler or something. And I was wondering what that thing was all about. But anyhow, I got that fixed up. But, U.S., you had that incoming ballistic missile warning that couldn't get canceled because the governor had lost his Twitter password or something. But in Canada, we had one a couple of years ago in Pickering. My sister lives there. That's the largest nuclear power plant in Canada. And it was like 8 o'clock in the morning on a Sunday. It issued a CAP alert, said that the power plant was in process of having a meltdown, and the thing everybody's cell phone is going off, radio is beeping, cable TV, everything, and everybody just looked at it as, oh, well, I guess maybe they'll get the thing fixed later on. It took hours to get that thing canceled, and I'm surprised about that because that's what happens with these boxes. You don't have control of being able to turn on and off the emergency alert. That's the built into the cap feed. They have an expiry, or they can issue a disconnect to rescind that emergency alert. But you're obliged to carry whatever goes over that thing as an emergency alert. So very important. That's why they do testing twice a year and stuff. So we haven't seen the end of mismatches. Yeah, there's zombie alerts that get issued by accident. So no shortage of that stuff. What's really important though is that we don't overload that emergency alert system, so that when people hear an emergency alert, the first thing they do is not one of those things, and hit the mute button.
Right. Vincent, do you have a story you can tell about this to leave our listeners with as we head out?
Yeah, I have two real quick, a Canadian one and an American. I'll try to tell them fast because I know we got to go. On the American side, I was listening to weather radio, and the National Weather Service, they do that weekly test. And my office, they will do a live voice for the weekly, so they don't do it with the computer voice. They accidentally selected required monthly test when they meant to do required weekly. And I seen that on my weather radio. I went and I turned, I had a Racket EAS boxes hooked up. I just like to play with that stuff. And I seen them all relaying, and I'm like, oh dears, they've really done it. And I pull up my radio, and sure enough, the local primary is sitting there relaying the monthly test. That's not a monthly test. So that was one, and I thought, oh goodness, I hate to be that person. They might have lost their job. I really don't know. The other one, the Canadian one. So I have a Alert box here, the Obi player that I do development on, and I have alerts turned on it from time to time, connected to the real thing just to see what's going on. I have friends up there like Rob and such, and I got an alert. I can't remember where it was from. I want to say it was the province of Ontario. And it was so funny. It was not a broadcast intrusive. So most broadcasters didn't carry it, but I had that checkbox on the player check to carry everything. I just was testing stuff. And it said at the end of a winter message talking about like there was going to be snow on the road from Environment Canada. It said it was from Environment Canada. At the end, I don't know if this was, some fluke or somebody did something they weren't supposed to, but it literally said at the end in the instructions section, it said, children will enjoy playing in the snow, but their parents will not like that. Something to that effect. And I thought, what the heck? I went back and pulled up the cap alert because it saves it. And I thought, yeah, that looks official. It's signed and everything. That I don't know what that was. I think that was somebody playing around and accidentally sent it.
So actually sometimes I'm sure others do it too, but our Nashville weather radio, sometimes I think they get bored and they want to just add a little levity to the forecast.
They get bored.
And so, yeah, I see wording it doesn't sound official, but it's not wrong either. So, okay, we'll let that slide.
Maybe that's what they were doing. It was official and they're like, yep, it was just got to say it.
Guys, we got to go. Rob, is there a last word you want to sneak in before we say goodbye?
Oh, no, but great to hang out with you and Vincent and everybody out there in Radio Land. Always interested in your show, Kirk. You have some really good questions, and thanks for sharing with everybody all the great stuff in this week in radio technology.
In the show notes, I will put some links to some of the things that you provided me with regard to the conference that you attended about CAP. And if you have any other links that you want me to stick in the show notes, go ahead and send them to me tonight, and I'll pop them in the show notes for everybody. All right.
Sounds great.
Cool.
Good deal.
Cool.
All right. Thanks a lot. Rob Hopkins and Vince Maggard have been our guests here on This Week in Radio Tech. Of course, Suncast has been our producer. Thank you, Suncast, for being quick on the buttons, even setting up the incredible triple shot. I appreciate that very much, Suncast. Thank you. Suncast is our show producer. And also thanks to Andrew Zarian, the founder of the GFQ Network. That carries This Week in Radio Tech every week. All right, we got to go. Be sure you visit our sponsors and tell them that you heard about them here on This Week in Radio Tech. It really helps me. If you're watching on YouTube, please like and subscribe. The team. And if you want to put a comment in the comment section on YouTube, that'd be great as well. It helps feed the algorithm, or maybe it's Al Gore's rhythm. But anyway, that's what I hear. All right, we'll see you next week on This Week in Radio Tech. Bye-bye.